In this video, we'll be having a look at the following maths problem. Prove by induction that for all positive integers n, 1 cubed plus 2 cubed plus 3 cubed plus ... up to n cubed is equal to n squared times n plus 1 squared divided by 4. And you can see the left-hand side is the sum of the first n cubed numbers. So this is proving a formula for the sum of the first n cubed numbers. If you like, you can go ahead and pause the video and have a go at the problem yourself before having a look at the solution. Okay, so now let's have a look at the solution. We'll be using mathematical induction in this solution. So we'll be starting with the base case of n equals 1. We have the left-hand side is equal to just 1 cubed when n equals 1. So 1 cubed will be equal to 1. And the right-hand side, let's make a slight adjustment, a slight error here. Should say, if you substitute n equals 1 on the right-hand side, we'll have 1 squared times 1 plus 1 squared divided by 4. And this is equal to 1 times 4 divided by 4, and this is equal to 1. So the left-hand side and right-hand side are both equal to 1. And this means that the base case has been proven. Now we move on to the inductive step, where we assume that 1 cubed plus 2 cubed plus ... plus k cubed is equal to k squared times k plus 1 squared divided by 4 for some positive integer k. And now we have to prove that the statement is true for n equals k plus 1. So the left-hand side of the equation, the sum of the cube numbers for n equals k plus 1, will have the left-hand side will be equal to 1 cubed plus 2 cubed plus ... plus k cubed, and then plus k plus 1 cubed. And we can see this contains the sum of the first k cubed, so we can use our assumption over here and substitute k squared times k plus 1 squared divided by 4, which is over here. And now we're adding the leftover k plus 1 cubed term. Now we can see that there's a factor of k plus 1 squared in both terms, so we can factor that out, and we have k plus 1 squared and times k squared over 4 plus k plus 1. Now we bring it under a denominator of 4, and we'll get k squared plus 4k plus 4 times k plus 1 squared. And k squared plus 4k plus 4 factorizes into k plus 2 all squared. So we'll have k plus 1 squared times k plus 2 squared divided by 4. And we can write the k plus 2 as a k plus 1 and plus 1 again. So now we have this equation. And now we can see this over here is equal to the right-hand side when n equals k plus 1. This means that we've proven that the left-hand side and right-hand side are the same for n equals k plus 1. So this means the inductive step is complete. And this means that the original statement we are trying to prove is true by mathematical induction. So we've proven that the sum of the first n cubed numbers is equal to n squared times n plus 1 squared divided by 4. And this completes the solution. And have a side note over here. So if we use the formula for the arithmetic sum of first n positive integers, so using the arithmetic sum formula for the first n positive integers, we'll have the sum of the first n positive integers and then squared is equal to n times n plus 1 over 2 and n squared. So this is the formula for the sum of the first n positive integers, and then you're squaring it, and you have n squared times n plus 1 squared divided by 4. And this is equal to the right-hand side of this equation over here. So this means you can write the sum of the first n cube numbers as the sum of the first n whole numbers and then squared. So this is another formula for the sum of the first n cube numbers. Okay, that's all I've got for this video. Hope you enjoyed this video. Thanks for watching, and I'll see you next time.